All right, let's continue our endeavor on solving the exam problems on this topic: variance, standard deduction, and coefficient of variation for the Maharashtra State Board Diploma, first year basic mathematics 22103. And this is a continuation video. This is a part 4 of the series. You should check out the first 3 parts where we are trying to break down the problems. And in specific, we are trying to solve type 3 problems on the variation and the SD and the CV. SD is standard deviation and CV is coefficient of variation. So we are dividing the problems in those categories, and within type 3 we have been, in the last 3 episodes, we have been solving different variations. In this episode we will see another variation of the type 3. So what we'll do is, if you see the problems for the last 4 years starting winter 2019, there are typically 2 types of problem that comes in this variation only I'm talking about for calculating the SD. So one is ungrouped data, and you might have to recall what is ungrouped data. This is just nothing but a raw data. Check out my earlier episodes on mean. And there will be something called as group data, where the data itself will be bucketed like this in a particular range called as class interval over here. So these are the 2 variations that we might get in terms of high weightage of marks. This will be for 4 marks and this will be for 6 marks. So let's break this apart. The ungrouped data, this kind of problems where they just give you some data and just ask you to calculate one measure, standard deviation, has appeared only twice. Once in winter 2019 and I think other time in over here in winter 2017, again for 4 marks in question 2D, where they gave you this and then try to find just one measure, standard deviation, for ungrouped data. Otherwise, for the most of it, you get a 6-mark question like this, where you have to find 3 pieces: mean, SD, and CV, and it will be always for a group data. So that's one major variation. So what we'll do is, in this video, let's just solve these 2 problems which are related to ungrouped data, and we need to find SD for that for 4 marks. So let's just solve these 2 problems, and in the next episode we will just take this grouped data and solve this kind of 6-mark big weightage problem separately, so that we are not confused, but they'll be related, and we'll apply the same principles of what we need to do in ungrouped data and what additional we need to do in terms of group data. All right, let's jump into the problem. So I'm going to take those 2 problems specifically, and now we are going to solve and talk in this episode only about finding standard deviation for ungrouped data for 4 marks. So let's take the winter 2019 problem, and it's a straightforward problem. We have given certain values 1 through 7 in sequence, and we need to find the SD for this, standard deviation for the data. Okay, and just as a quick recap, or before solving the problem, after reading the question, these are the things that needs to run into your mind immediately, kind of flashing in your mind looking at the question. First and foremost, the data given is ungrouped raw data. It's a raw data. There's no grouping, there is no class interval, just straight data. That's the first thing. And whenever we have been asked to find standard deviation or variance or coefficient of variation, any of these 3, always remember the first step is going to be finding the mean, the x bar, because all of these measures of variability are based and derived out of mean. So always remember that, and all of them are related in a way. So if you find mean, everything has a mean component within that. SD is also derived out of mean, so is variance, and so is kind of CV. So always remember that. So always remember that as a hint whenever they find standard deviation. In case you're stuck in the exam on where to start, the first step is to find the mean of the data, and in this case it's a group data. So it's a simple arithmetic mean where you divide everything over here. You add everything and divide by the total number of values. Okay, total number of values is going to be 7, and we'll see that. Okay, and in terms of sequence, what we need to do is always we need to find the mean first. We have covered this, and the right way to look into that is first find the mean, then find the SD, and then find the variance. So that means sorry, I messed up here. So what you do is, first you find the mean. For finding standard deviation, first you find the mean, then you find the variance, and in the last you find the standard deviation. So we have M, V, and S. So this is the sequence you need to follow always: M, V, S. okay, because SD is nothing but a square root of variance, and variance is derived out of mean. So MVS is the strategy. So that means for finding standard deviation for this problem or for any problem, we need to find the mean first, and then the variance, and then the SD. And always use the table format to do the calculations because it is very easy. Now let's get into problem solving. Okay, first and foremost, we have all the values here where we see 1 to 7. The total, we have got 7 values given in the sequence. Let's write it down. So if you see here 1 2 3 4 5 6, I've written all the values here. That means that n is equal to 7. In this case, the number of values, this is 1 2 3 4 5 6 7. So n is equal to 7, and this values are also the x for which we need to find the mean. Okay, hence we need to add that. So when I add that, when I do a sigma x here, this is a sigma x. So I'm adding this 1 plus this plus this plus this plus this plus this. The answer is going to be 28, and I have the total value is 28, and the given number of values are 7 because I counted this individually. So the mean is going to be x bar is equal to 28 by 7 is equal to 4. That's your first step. So the mean I've just written for simplicity as 4 in every column so that we can do the maths. Okay, so we got the mean as 4. And since we are going to find the standard deviation, after finding the mean, what we need to do is we need to find the individual deviation. That means how far is this value, if this was a number line, for example, if this is a number line and here is 1 and let's say here is 0, this is 0 and this is 1, and let's say this is 4, which is the mean. So this is the mean, okay, this is the mean line. So what we're asking is, in terms of individual deviation, how far is this point, the given value x, this point, what is the distance between this point and this point? That's what we need to calculate, and that we calculate by subtracting the mean from the value itself. That means in this case, how we'll subtract? We'll subtract, say, in this case, we'll subtract 1 minus 4, and that's going to be minus 3. This is what we get here, and so on. We'll be finding for each value. We're going to take this and minus this, 3 minus this, 4 minus this, 5 minus 4, so on and so forth. Okay, and once we find that, we'll have the individual deviations, the difference or the deviation of individual value x from the mean. That's what we'll have. And if you recall, the very reason that we have a problem in this is for taking the mean is when you add all those things, you'll see it comes to 0, because the negative values cancel out the positive values, because there are equal number of negative values in terms of total negative values and total positive values. In terms of, if you add all these things, it becomes 0, and hence we cannot take the average mean, the mean of the mean, we cannot take it. And that's what I discussed when I spoke about mean deviation and why we need variance and stuff like that. Just a recap. And hence what we will do is we will need to get rid of the negative values, and one of the ways to get rid of the negative values is square that, because that way we can find the variance, right? When you square and take the average, we get the variance. So first thing is, let's square the individual deviations. That means we're going to square this, we're going to square this, we're going to square this, this, and this, and this, and this. That's what I put, x minus x bar. This whole thing that we are seeing here, we're going to square this. That's what we're going to do. And once we square, we get these values where each number is a square and the negative sign is gone because we have squared, so all the values are positive. And now we are going to find the variance. For finding the variance, what we need to do is we need to add all these values. If you see here, all these values we need to add. That is that, so for example, we have x minus x bar the whole square, and I'm using this sigma sign as a summation to add those values. So I'm going to add each one of these values over here to get the value of 28. Okay, and now I need to take the average of this value over the number of values, which is the n, to get the variance. So if you see, I put the n here, and the numerator is going to be 28. So if you see here, 28 divided by 7, which is the n in the denominator, and I'm getting the value of 4. So my variance, which is sigma square, is equal to 4. And I very well know that now I have found mean. For example, the formula where we have put MVS over here, we are following that. So I have found the M here, the M part is found here, the V part is found here, and this is my S part, standard deviation, the last step. So what I'm going to do is, my standard deviation is sigma is equal to the square root of the variance. Both variance and sigma SD will have the same notation, but variance will be always expressed in terms of the square, and hence we need standard deviation because we need the value back. So we are taking the square root. So in this case, we're going to take the square root of 4, which is 2, and whatever you see in green is your final answer. So the answer to this question, when they ask you find the standard deviation is equal to 2. That's your final answer. So that's how you secure your 4 marks. And I also copied the steps from the episode where I explained the theory part of it, so that you understand that how to calculate. For example, the first step we did is calculating the regular mean. You don't have to, this for just reference. There is no need of writing this in the exam, just for reference. Okay, but it kind of cements the rules on what you need to do step by step. The first thing is calculate the regular mean or average, as we know, which is what we did, calculating x bar or MVS, the M part. And then we take the individual deviations, which is the difference between the number and the step, like how I explained in the number line over here. We took that individual difference, which is x minus x bar. Okay, let me take a different color of this thing. And then what you do is you square up all the differences from step 2, make it positive. This is what we have done. We're getting in preparation for getting the variance, and then we add up all the square differences and then divide it by the total number of values. So 4 and 5 will give us the variance, which is what we do here. There's a combination of 4 and 5 steps where we have found the M now, we have found the V, and the last step is S, which is the SD, standard deviation. And taking the square root of variance gives us the standard deviation, in which the answer is going to be 2. So that's how we calculate the standard deviation for ungrouped data. So I'll take another example, but I'm not going to repeat all the steps, but this is how you need to remember the hints and these things. So let's take another example which appeared. Now it's the same kind of model, but different values. So in this case, now we have got 8 values from 15 to 9. So we're going to take step by step. We are going to find the mean first. I'm putting all the values in the column 1, writing it down and adding it up, so that this is 128. All of this, if I add up, is going to be 128. The total number of values is 1, 2, 3, 4, 5, 6, 7, 8, and hence n is equal to 8. And once I get this ratio, I'm going to get the average, which is 128 over 8. If you see here, 128 over 8, 16. 16 is my mean, and I've copied here. So I got my first step done. Out of the MVS, I've got the M, and I've copied the mean over here. Then I'm going to take the individual deviation. That means how far is this value from this mean on a number line. So 15 minus 16 is minus 1. So I'm going to just subtract this, each one of this minus this minus this minus this, x minus the x bar. Okay, and x is this value. I'm going to get the individual deviation from the mean, and I need to, some of the values are negative, and if you see I add up all this, it becomes 0. That means I'm not going to find the average, because if I use this in the numerator, it's going to be a 0 value. Hence what I do is, to find the standard deviation, I need the variance. In preparation for getting the variance, I square the value to get rid of the negative value over here. So all these are positive values expressed in square, x minus x the whole square. And then once I add those up, now if you see here, I was getting 0 value, but now once I square and add it, once I square and then add it, I'm getting the value of 310. And 310, if I divide it by the numerator, by the number of values in the denominator, which is equal to 8, so 310 by 8 is my variance over here. If you see 310 by 8. So variance is nothing but sigma square, and this is the formula. I'm adding that. And once I get that, that is my step 2 that is completed. Out of the MVS, I've got M, I've got V, now S is pending, with a standard deviation, and that's very simple. Take the square root of the variance, whatever you have, and then you get the standard deviation, and the square root of 38.75 is going to be 6.224. So this is going to be your final answer. So that's pretty straightforward, kind of how you should calculate standard deviation for ungrouped data. Simply tabulate the format, and just remember you have to find the mean, then the mean deviation and the variance, and finally the SD. So follow the formula for M, V, S, and that way you will not miss it. So that's securing your 4 marks for ungrouped data for standard deviation. And in the last and the final episode, hopefully in the next episode, we'll be talking about finding the the three portions, mean, SD, and CV, for group data. And it's going to be the same but two extra steps, but we need to be careful. So we'll find that, and then should conclude your 6 marks along with covering the whole syllabus from an exam standpoint of view on this topic. I'll see you in the last and the next episode.